Okay, let's talk about Ohm's law and circuit power problems. We're going to look at some very basic, simple problems. Remember Ohm's law, I refer to as V equals IR, says the voltage is equal to the current times the resistance, where the resistance is a property of your elements of your circuit. So this is a light bulb. This is a wire. This is your toaster. And the resistance doesn't change with the voltage or the current. You can adjust voltage and that will change current. So this is a property of the material. And as a matter of fact, if you are to graph V versus I, of course, the slope of this line for an ohmic resistance, the slope is R. Now the power, there are three different forms you can use for the power. Power is IV, PIV. And so I'm always talking about Piv and Veer and how good friends they are and how they're always kind of hooking up. And we can rewrite Piv by introducing Veer in. And if I replace this V here with IR, I get that the power is I squared R. And if I replace the current with V over R, I get V squared over R. Now, I got to be honest, I don't remember these two. I remember Piv and Veer, and then I work from there. So let's see. I have a 1.5 volt battery. Now, this is pretty straightforward because V is 1.5 volts. It's connected to a small light bulb with resistance of 3.5 ohms. So my resistance is 3.5 ohms. Okay, what's the current? Well, V equals IR. I'm looking for current. So current is V divided by R. So this is 1.5 volts divided by a resistance of 3.5 ohms, or 0.429 amps. Now, I have a 1050 watt electric toaster, operates on a circuit of 120 volts. All right, so my power is 1050 watts, and the voltage is 120 volts. What is the resistance of the wire that makes up the heating element of the toaster? Well, let's see. P is IV. I told you, I always start with this one. And I know V is IR. So I'm going to plug this in, and I have I times IR. No, I don't want to do that. Again, mistakes happen. I don't want to do that one because I want resistance in there, don't I? I can cheat and go back and figure out which formula I want. I want to get rid of I because I don't know I, and that's V divided by R. Ha. This is what you do if on the test you forget the formulas. So power is V divided by R times V. So I'm looking for the resistance. By the way, this is V squared over R. So I'm going to clear my fractions. So RP is V squared. So the resistance is V squared divided by P. So the voltage is 120 volts. And I'm going to square that divided by the power, which is 1050 watts. And I get a resistance of 13.7 ohms. I mean, you can go on and give all the sig figs, but you don't need to. Now, an electric heater is operated by applying a potential difference of 50 volts across an acromium wire with a resistance of 8 ohms. Find the current. All right, this is clearly the voltage. And this is clearly the resistance. So V is 50 volts. R is 8 ohms. So V equals IR. So let me continue this up here. I is V divided by R, which is 50 divided by 8, or 6.25 amps. Now make sure you're showing me all of these steps. Some of you are starting to get a little bit sloppy on your homework problems. Now, what's the power rating of the heater? Well, let's see. P is IV. This is my favorite one. So this is, let's see, the current we have is 6.25 amps, and the voltage is 50 volts. So I get a power rating of 312.5 watts. Now, could I use one of the other formulas? Of course I could. If I took, let's see, V equals IR, and I plug V in here, I would have P is, let's see, V is V squared divided by R. So the voltage is 50 squared divided by R, which is, let's see, what's my resistance? 8. So that's 25. 0 divided by 8, or 312.5 watts. Okay. So suppose I could use the other version as well. Let's see, what is it? I solved I is V over R, and R is V over I. V is, oh, IR. So P is IR, so it's I squared R. So it's 6.25 squared times a resistance of 8. Lo and behold, 312.5 watts.